yeah, we start the recording and let's take it from here. Couple of things that we need to understand is there are a few more small bits remaining in the force acceleration motion chapter. So I'll be going through that, and then I'm going to cover the topic for momentum, which is newly added to your syllabus, for which I'm really happy. And then we'll pick up the idea for momentum from there. Did we discuss about the logic of momentum with you? Did I discuss that with you?
Yes, sir. We discussed it while doing the second law of motion.
Did I discuss with you the conservation of linear momentum, that m1e1 plus m2u2 equals to m1v1 plus m2v2, that equation? Did we go till that far?
Yes, sir.
Then we have covered momentum, which is nice. I actually forgot that momentum was whether momentum was covered or not. So there's only actually a very small bit remaining, which is the idea of the reaction time and the thinking distance and the blah blah blah. So let's get to one thing. We human beings has a very simple thing in our biological system, which is called reaction time. Reaction time is basically sort of like the lag of our biological nervous system. I'm using the term lag for those of you who play a little bit of network games, MOBAs or anything like that. You guys know what lag is, which is sometimes referred to as the ping as well. However, reaction time for human beings is something like this. Let's say we are going to receive a certain impulse that may be visual information, maybe audio information, and we need to work something, or we need to give a physical response out of it. For example, one of the very simple common example, let's say you are standing in a normal place, a fly or an insect comes by and make a small contact with your face and flies off. Usually, unless you are prepared for it, we don't ever can actually swat that on our face. I mean, although our face is actually very sensitive, the concentration of nerves within our face is actually very high, but still the sensing that there is something on my skin and processing that information, sending the impulse to our hand muscles to contract them and eventually being able to perform that action actually takes a little bit of time. This delay between receiving the information to our system and being able to perform the next action with respect to that actually takes a little bit of time. This is what we call reaction time, and reaction time is a very common phenomenon for every human being, no matter how well put. Well, people can improve their reaction time by practice a lot. That's basically how good batsmen become good batsmen in all the for example, in cricket or in baseball, in these sports, because the thrower or the bowler actually bowls the ball pretty fast, and then they have to react pretty fast that how their bat should move so that they could actually do a good run up. Anyway, so reaction time can be modified for sportsmen by a lot of practice, by a lot of repetition, by building up muscle memory. However, a typical human being has a reaction time, standard human being, I'm using the word standard human being, means a grown-up person who is well rested, not sleep deprived, not intoxicated, and not otherwise out of their regular thinking process. I mean, not or is it not distracted by any other physical thing. So regular human being usually have a reaction time of about 0.4 seconds. So this is the typical value. Some people can have more, some people can have less, but it can be significantly reduced by practicing the actions quite a lot. So because of this reaction time, we can have a little bit of change in multiple different calculation for graphs as well. One of the things that the mathematical approach that we have within our syllabus for this case of reaction time is a very simple thing. Let's say there is a car which is right over here. This is a car with a bit of a head and headlight, and there is a person inside who is driving the car. Figure not drawn to scale. Let's say this car is moving forward at a speed of, let's say, 20 meters per second. Let's say the person sees a certain danger in front of him at some distance away from here, and is about to press the brakes. So let's say that instant when he detects the danger, let's say there is another person, or there's a bear on the road, the person wants to apply the brakes of his car so that he doesn't hit the bear. let's say the instant when he receives that information is t equals to 0. Now his immediate response should be to press the brakes, and which should work through the braking mechanism of the car, and then there should be frictional forces working between the tires and the ground, which should eventually bring the car to decelerate the car to stop. Now, to make that happen, the person needs to apply the brakes first. So the thing that happens, the person cannot apply the brakes immediately, because within this time amount of 0.4 second, the car is not going to start any acceleration, decelerating force on the wheels. So if I try to plot the VT graph of this person for a scenario starting from the, let's say this is a speed time graph of the object. So let's say this is V given in meter per second and T given in seconds. And let's say this is our zero value. Let's say the initial speed of the person was 20 meter per second, let's say, which is right over here. And the person keeps on going for that same speed for 0.4 seconds. So let's say this figure, none of these scales are drawn to scale. I'm just highlighting some numbers over here. Let's say 0.4 seconds is over here, or it could be more than that, depending upon the person, whether the person is tired or the person is a little bit of intoxicated or something like that, or maybe old. That also affect the reaction time of people. Not all people, but most people. So within this time, the car is going to maintain its uniform velocity at 20 meter per second. After 0.4 second, the brakes are going to be actually pressed and the car will actually start to decelerate. And for the sake of convenience, for the sake of easier math doing, let's assume that decelerating force is a constant force causing an uniform deceleration, by which the car comes to rest with an uniform deceleration and eventually comes to rest over here. Maybe that amount of time can be, let's say, maybe 3.0 second. So like I said, this figure is not drawn to scale. So this much is 0.4, this much is 3.0. This doesn't make sense, but like I said, this figure is not drawn to scale. There are multiple different names that we give to the different distances covered under the VT graph. These are the names that you need to get acquainted with. You need to know what are the names of the different distances that we are covering over here. So this is called this much time. So this much time is what we call the reaction time. This much time is what we call the braking time, where the actual braking happened. And the sum of these two, total thing, the all of it is called stopping time. So that's basically from the beginning of the observation all the way to the coming to rest. And if we are trying to find out the distance that the car covers within the whole example, we can find out the areas of these two scenarios. The amount of distance that the person covers while the reaction time happens is what we call the thinking distance, which is the area of this rectangle. So this is thinking distance. And the area under the deceleration, actual deceleration of the car, which is this, the area under the triangle, this is what we call the braking distance. You can see braking time and braking distance. And together, if we sum this up to the whole of this thing, this is something that we call the stopping distance. So it's actually not so much of a difficult to remember this thing. One simple part that the way I usually keep track of it is that for the duration the braking actually happened, we call it braking distance. The total thing is called stopping, and the other things are called the other things. So the reaction time is called reaction time, and the distance covered within the reaction time is called the thinking distance. Reaction time can actually I mean, thinking distance is actually a very important factor for the designing of cars and also for the braking force for a certain road. Because in most cases what happened that typically a well-maintained car going on a regular road means a dry, non-sandy, non-wet, non-slippery road. A regular road can usually achieve a pretty significant braking deceleration if the braking systems are well maintained and the car is not no, you don't have to note it down, just try to understand it. It's still within your class notes. So if the car is well maintained. So actually thinking distance in most cases can lead to a lot of disasters if people are not careful for their thing. And this is also why operating any type of cell phone for texting, looking out for any notification, or trying to send some message or anything like that, uh, is actually can prove to be very deadly if someone is going on a road where there is a possibility for accidents. For example, if you have boundary wall covered highways, then that might actually be not a big deal unless there are other lousy drivers cutting into your lane. But if you are going through a regular highway where the two sides are open and wild animals, people, zombies and bears could possibly cross the road, and then you don't want to hit those things, operating cell phones or other getting distracted while someone is driving is really not recommended at all. uh, One of the things that I can actually show you for this whole part, I mean, the distance that is covered is actually increases linearly with time. So 20 meter per second is actually not that much of a high speed, but more or less quite a high speed. So that's the basic idea for this part. The other variation for thinking distance or the reaction time graphs, time-based graph that can happen is whenever we have, let's say, there's a scenario where we have a car, which is over here. People inside, and this person is standing in a red signal of on the road. So let's say this is currently red, and then the red signal is about to go green. So the person is waiting for the light to go green. And if we try to plot the graph for the speed time graph for this scenario, when the t equals to 0, I mean the time is 0 when light turns green. So the instant the person sees that he is supposed to start going is where the uh, graph's time measurement is getting started. Usually what happens, the car usually doesn't start to accelerate the exact instant the lights go green, because 1 second we have a reaction time. So if you start observing this graph right from here, let me draw that with blue. For a small duration of time, the car actually remains stationary on the road. Let's say that amount of time is about the reaction time, maybe approximately 0.4 second. Let's say 4 second, and let's say this is drawn in meter per second. Figures not drawn to scale, I just wrote those units just to give you an idea that units are a very important part for any graph. If we want to write numbers, units are very important, but if you want to only draw a sketch of the graph, units are usually not that important. So for that duration, the car might remain stationary, and then from this point onwards, the car is going to start to accelerate. Typically, the accelerate doesn't actually bump into a pretty high value. In many cases, the acceleration of the car can be shown to be like this, to be a perfect straight line starting off from the very same point and having a perfect straight line all the way, and the car accelerates upwards. And eventually, after it reaches a certain speed, it might actually become it might maintain that speed, which is the what you call the cruising speed for a certain car. I mean, different people prefer different level of speed for the safety reasons, and for safety, different road also have a maximum speed limit, so people shouldn't drive above that. So in many cases, this accelerating line might start as a perfectly straight line from the endpoint of the horizontal segment, but in reality, in true case, it actually never takes a sharp turn like that. I mean, it's not very much visible over here because I overrode this region a lot, but the actual crossing that happens over here is actually something like this. So we have a flat section of the line, and at the end of the reaction time, we had a perfect straight line. So practically there is a corner over here. But in true case, the velocity of an object actually doesn't start to take a hike like that. Rather, the more realistic scenario is velocity of the car actually starts to go up, being in a smooth curve like this. So the velocity usually goes up like that. It doesn't have to be more steeper than the original line, but my point being that the velocity of increase of a car when the accelerators are pressed usually go on like that. So it usually goes on like that. The reason we have a bit of a curve over here because for the force to work from the car machinery through the axle, through the wheel, and to the ground and get the reaction force back, it actually is a gradual step. Different cars can have that amount of time. I mean, how much curve should you have there? If you have a really sharp corner, it means you are gonna start to experience the acceleration really rapidly. So different cars also have, I mean, the internal mechanism of a car can also lead to a certain amount of delay. For example, internal combustion engines, which are petrol engines or diesel engines, they actually have a significant amount of delay for between pressing the accelerator and the wheels actually starting to move forward. So there is a certain delay. But electric cars, for example, all the electric cars that is currently available, for example, Tesla Motors, and now I think there are some certain Chinese models which are also very popular, and I think Audi is also making a really nice electric car, which is currently available to buy, but not very popular yet, but still available to buy. So just because just an off-topic thing, I just remember something. Do any of you follow the development with SpaceX? Any of you? I mean, what what SpaceX have been doing, or such things like that. Okay, sometimes. Well, SpaceX just recently stacked the Starship launcher with the Starship, which is the first time, and they successfully did the launch thing of the Starship launcher, which happened almost flawlessly. So they might actually start to use the booster with the Starship pretty soon, which is really good news. For those of you who have no idea what I'm talking about, it's okay. For those of you who have some idea what I'm talking about, excited time to be alive. I mean, exciting times to be alive. Anyway, so different cars have different type of acceleration. So in reality, this line beyond the point of the reaction time is actually not such a sharp acceleration gets started. That's the most realistic scenario. But for the sake of simplicity, in many cases of your graphs, you might actually come across this kind of sharp corners, which is also perfectly acceptable and whatnot. That is that other thing, and I cannot recall of anything very important to that we have within our syllabus. So I'd like to help you solve the couple of problems that I gave you the earlier day, and would like to discuss some more problems for today's class as well. So could someone actually send that image? Who is this? Student, parents? I don't recall. পরে দেখবো। কেউ একজন একটু লাস্ট ক্লাসের ছবিটা পাঠাও, প্রবলেমের একটা ছবি তুলে এখানে পাঠাও, কারণ আমার নিউমেরিক্যাল ভ্যালুগুলো একটা মনে নাই। I would appreciate this.
Sir, I had a question, sir.
Yes, go ahead.
It's on another law of conservation of momentum.
Yes.
Sir, we studied the case where two cars before collision, they were moving in the same direction. What if they actually moved in the opposite direction? Like one was moving to the right and another one was moving to the left.
Oh, though that's pretty simple. That's pretty simple. Did I show you the derivation of that process? That how did the whole equation came into being?
Yes,
maybe I did.
Using the third law, I think.
Fine. I'll help you understand this thing. The way we derived that equation is that object 1 was going to the right and object 2 was also going to the right, and that's why we consider then m1, e1 and e2, and in this case e1 was bigger than e2, so that the collision would happen. So and then we had the collision where the objects were experiencing forces. Let's say this is f2 experienced by object 2 and f1. So this is before collision, this is during collision, and after collision we're gonna have the two objects going in the exact same straight line towards right as well. This one is smaller and this one is bigger. So that was the scenario that we considered. The reason we went for such a simplified view, because we considered towards right as a positive direction for our mathematical generation. So that as a result, whenever we start from this expression, we actually can write that minus f1 equals to f2, which brings us minus delta P1 divided by T equals to delta P2 divided by T, because force was working, F1 is working towards the left direction, that's why we divided a minus. Eventually, if we place all the numbers over here, ultimately we got this thing, M1U1 plus M2U2 equals to M1V1 plus M2V2. This was the law of conservation of energy, let's say law of conservation of linear momentum for our syllabus. Now, important bit, this equation was derived under the premise that all the velocities involved for our ideal scenario were all working to the right. So that's why there was no negative sign. This is what we usually do. If objects are moving in opposite direction, one with respect to the other, then we have to consider one direction to be positive. Here, I consider towards right as a positive, but there is no hard and fast rule that you always have to do that. This is the most common practice, but not necessarily the obligatory practice. Sometimes you can also consider towards left as the positive direction for certain mathematical problems that can also be a little bit of helpful. However, if it so happens that, let's say for a certain mathematical case, we are having a situation where two objects are approaching each other from opposite direction. Let's say this object has some mass of 10 kg, this object has some mass of, let's say, 5 kg. This object has a speed of maybe 15 meter per second to the right, this one has a speed of maybe 20 meter per second to the left. So in this case, if this is the scenario before collision, then you have to judge one of the directions as positive. So if I consider towards right as positive for this scenario as well, so I'm going to write this whole equation. The left side of the equation is going to look like this: 10 multiplied by 15 plus 20, sorry, not 20, plus 5 multiplied by minus 20. So you have to understand that U1, U2, these are velocities. So they highly dependent on their direction as well. If we have two objects coming in opposite direction, then one of the velocities should be placed as a positive number while replacing the variable in the equation, and the other variable should be replaced with a negative number. Does that answer your question?
Yes.
So that's that. আমাকে কেউ একজন একটু হোমওয়ার্কের কোশ্চেনের ছবিটা পাঠাও। আচ্ছা পাইছি। Oh yes, thank you.
So, sir, the
Lifesavers.
number you gave, sir, the number you gave on Messenger for the Bikash number, my mother wanted to check if it's actually valid or not. So she was trying to call that number, but no one picked up. So do you have any number or something my mother wants to talk about it?
Yes, I can be reached another GP number at which I don't have the Bikash account, and my Bikash account phone has been out of charge for the bigger part of the day yesterday and today as well, because I don't usually use that for any of my purposes other than only receiving Bikash payment. So I have put it into charge. So whenever it gets a little bit of charged up, I'm gonna turn it on. If your parents want to talk to me, they can reach me in this number. This is the number I usually give out for to my students.
Okay, thank you, sir.
And the other Bikash number, which is 0615324725, is definitely in effect. That's my only Bikash number.
Sir, I had a question.
Yes, go ahead.
Sir, it's not regarding physics. Like, sir, Google the collect original, right? Timing the coupon every day.
I mean, I couldn't hear you right. Please কখন আচ্ছা মানে ওয়ার্কশিট পিক আপ করার জন্য, হ্যাঁ বলতেছি, ওয়ার্কশিট পিক আপ করার জন্য the coaching is usually open from around 9:30 10 a.m. in the morning, and it at the evening I think it closes by around 8:30 ish.
So sir, I can go there at any time during this time.
Yeah,
to collect the worksheet.
logically yes, because we have two person to attend the students, and by design, by routine, none of them actually leave the coaching simultaneously. At least one of the person would be definitely there to receive you. The answer is yes. The answer to your question is yes.
Sir, if one of my friends go to collect the book, collect the thing, can they collect it for me as well?
It's possible, but your friend should have the full information of you, roll number, name, and also roll number and name. Yeah, that's pretty much it. and the first booklet collection. So they, yes, they can, but they should have your full information.
Okay, okay.
It's always best if the information is written in a piece of paper.
Sir, I didn't got my roll number yet. I knocked your assistant, but I haven't got anything from him.
Your নাম কি?
Sir, Taisir Rahman.
তাইসির রহমান, ওকে ফাইন। আচ্ছা, আমি তোমাদের ক্লাস শেষ হওয়ার পর মামুনকে বলতেছি, he will knock you and talk to you about your roll number. No big deal. This will be done. Acha, I have these images over here in the same orientation, so might as well copy that. Both of you, thanks to both of you for sharing the questions. I really appreciate this. I'm just using this because this is in a single image, no big deal. So I'm going to help you solve this problem, and today we're going to solve some additional problem from for this topic as well. Some of them are going to be from momentum as well, not the worksheet problems, but some problems I'm going to give you, which I find should be interesting for you to attempt. So what did you get for the answers? Can I have some numbers? Did you try this? Anyone? Oh, you can tell it, no big deal. You can voice it through to the voice channel, no problem. So one of your friend is telling that the answer for 1A was 20 meter. Okay. And B is, I think it should be 4 seconds. Acha, anyway. Acha, Ryan, thank you. Thanks for the number. So one of my friend actually asked, I assume this is 2 seconds, but I'm gonna solve the problems anyway. I hope you attempted your homework. I'm not actually going for a hard check whether you really attempted your homework or not, because I don't want to, and I hate COVID, and I hate not meeting my students in person. So I'm gonna solve the problems for all of you anyway. Yes, exactly. And that's precisely what you what was wrong? What was wrong with that? So I'm gonna solve the problems for you. If any of you have any question regarding the solution, please ask. I'm gonna be a bit quick about through this. So if you need me to re-explain, need me to slow down, please say it. So let's first define what are the information that we have available for us. So in question number 1, the question says that our initial upward velocity is 20 meter per second. And we do know acceleration due to gravity, which is working downwards, is minus 10 meter per second squared. Now I'm using minus because for my case, because I gave the initial velocity, initial upward velocity, because the question says the stone is thrown vertically upwards, because I wrote this number as a positive number. That's why downward acceleration, which is opposite to that, this vector has to be written as negative number. This is the important bit whenever you are trying to do calculation including vector quantities within your equation. You have to take into account the direction thing and apply plus or minus sign depending upon whether multiple vectors are working in the same direction or they are working in opposite direction. This is really important, can prove to be very useful and important for to get correct answers. So these are the two variables that we have. In number 8 says what is the maximum height reached. So one of the things that we can definitely ascertain is that at maximum height the final velocity should be 0. So this is going to be helping us for a lot. So we are trying to find out h equals to what. So try to have a look at the 4 variables that we have available. We need to make a equation which involve these 4 variables. So have a look what is missing from here. I can see that time is missing from this equation. Do everyone see that? We have U, we have A, we have V, we have H. H is just another expression for S. So this is also the displacement. So among these four variables, the missing variable happens to be time, which means we are going for the fourth equation of equation of motions. So I can directly write that V square equals to U square plus twice AS. So let me write these numbers. 0 square equals to 20 squared plus 2 into minus 10 into H. I'm using H because this was the case for a vertical height. If you want to write this as S, no problem. You can do that, no big deal. And that ultimately give me H equals to 400 divided by 20 gives me 20 meter. So that's the maximum height, simple as that. Number B, it says the time taken before reaching the ground. So this question can be solved in two different ways. One of the ways that can be, I'm going to show you all both the ways. One of the ways can be that we can try to find out how much time it takes to actually reach from the bottom all the way to the top. So we can try to find out how much time it takes to the top. Mathematically, we can find that out. And logic dictates if it takes certain amount of time to reach to the top, it should take the same amount of time to fall back down to the same level. That's just symmetry of motion. I mean, it goes up, slowing down, then it falls down, speeding up under the effect of same acceleration, under the effect of same gravitational force. So the rate of speed increase and decrease, that should be both same. So we can calculate how much time it takes to reach up to the top and multiply it by 2. That's one step. Or logically, we can find out at what time this object should be at the same initial horizontal level by mathematical solving directly as well. I'm going to show you both the ways. So for the first method, I have to consider that at the maximum height v equals to 0, and I want to calculate what is the time at which the object reaches the maximum height. So the variables that we have u, a, v, and t. Obviously, I'm going for the first equation because s is missing. So I can write v equals to u plus at, which brings me t equals to v minus u divided by a, which should be given as 0 minus 20 divided by minus 10, which gives me 2 seconds. So the time it takes for the object to for the stone to reach to the maximum height is 2 seconds. So but the question didn't ask me to find that. The question says the time it taken before reaching the ground. So time taken to reach the ground that's 4 seconds. So this is a simple way to go for it. The alternative version is that we can calculate that amount of time directly by using a little bit of quadratic equation. I'm saying quadratic equation because this is going to be part of our process over here. So the idea is that when the particle will once again start from here, go all the way up, and eventually fall all the way down back to the same level, the total amount of displacement would have happened is 0, because the particle will be back to the initial starting point. So the displacement would be 0. So, and we are trying to calculate the time where we have u and a available. So the variables that we have available over here is s, u, a, and t. T is the unknown. So if you have a look at these four variables are included in equation number 3, because we can see that the final velocity is missing variable over here. So I'm going to go for equation 3. So let's write that s equals to ut plus half a t squared. That's our third equation of motion. You guys don't have to actually memorize this equation. If you have access to the equation table, there are 4 equations over there. Every single time you need to use an equation, after you detect what are the variables that you need to make the equation with, take a look at that list and copy that equation from there for your working. Over the process of you practicing, eventually you will remember this formula. So don't bother too much to memorize them right away. You don't need that. You shouldn't do that. So in this case, to find the total amount of time directly, the total distance should be 0. The initial speed was 20 multiplied by t plus half into minus 10 t squared. So that ultimately gives me 5t squared minus 20t equals to 0. So if I just divide the both side by 5, I'm gonna get t squared minus 4. So 40. So if I take t common, I'm gonna get t minus 4 equals to 0. in the step I also divided both side. I divided both side by 5. This is just a symbol that I'm writing to make sense with you. Don't bother to add this in your actual exam. You don't have to. So this actually means that the value of well, you do know from mathematical processes that whenever the multiplication of two different variables is equals to 0, at least one of them has to be 0. So either t equals to 0 or t minus 4 equals to 0 equals to 0. So this brings us that t equals to 0 second. This is also possible, or t equals to 4 second. This is also possible. To be more clear, both of these answers are equally true, because what you need to understand, t equals to 0 is the amount, is the time when the object was actually shot from the stone was actually shot from the ground upwards. So the instance t equals to 0 represents the beginning of the journey. At that instant of time, the displacement was 0, and then the object rose up and eventually fell down, and at the instance t equals to 4 second, the displacement is once again 0. So by logic, both of the answers are perfectly okay, but you have to understand from the question actually asked us that the time taken before reaching the ground. So before reaching the ground means how much time is taken for the entire traveling period. So although this is logically correct for this logic, that s equals to 0, s equals to 0 যে logic, সেই logic এর জন্য t equals to 0 second is absolutely correct information, but we are not going to pick that up because we are asked to calculate how much time was required for this whole journey to occur. So our correct response is going to be 4 seconds. So you can either go by this method, or you can also really go for this method as well, whatever you find comfortable doing. Yes, Bolo.
Sir, I have a question.
Please.
Sir, in the first method, আমরা স্যার লাস্ট থেকে 2 into করলাম কেন? In the first method, b take, sir, 1b.
Yes, this is the 1b.
Yes, sir. V equals to u plus 80. Sir, এখানে নিচে দেখেন to reach the ground. এখানে আমরা 2 দিয়ে মাল্টিপ্লাই করলাম কেন?
ও 2 দিয়ে মাল্টিপ্লাই করলাম কেন? কারণ হচ্ছে আমি বলতেছি, এটা কারণ হচ্ছে this is the logic applicable for the maximum point. This is not the logic for when the object is going to come back to the ground. Try to understand what happens. We shoot the stone upwards at a certain high speed, 20 meters per second. It goes up and slows down, and eventually at the highest point of the motion, maximum height, it comes to instantaneously, momentarily at rest. ঠিক না? এরপর কি হবে? এরপর অবজেক্টটা ন্যাচারালি আবার ফার্দার ফল ডাউন করা শুরু করবে। যখন ফল ডাউন করা শুরু করবে তখন তার স্পিড আর 0 থাকবে না। We went for this logic just to find out how much time was required for the only going up process. So v equals to 0 যদি আমি apply করি, I'm assuming that the final velocity is 0. So for the entire going up and down motion, going all the way up and down motion, exactly at which point the velocity is momentarily 0, that has to be the maximum height point, right?
Yes, sir.
So ওই লজিকটা অ্যাপ্লাই করে আমি যে টাইমটা ক্যালকুলেট করতে, সেই টাইমটা অ্যাকচুয়ালি আমাকে কোন টাইম দেবে? সেই টাইমটা দিবে হচ্ছে আপওয়ার্ড ট্রাভেলিং এর টাইম কতটুকু। And because we are considering area is negligible, and obviously we are considering the object would be going up and falling down under the effect of same acceleration, তার মানে হচ্ছে সে যতটুকু ডিসটেন্স আপওয়ার্ড ট্রাভেল করবে ততটুকু ডিসটেন্সই ফল করবে। So which necessarily implies that the requirement of time would be exactly equal. So যদি উপরে ওঠার জন্য যদি 2 সেকেন্ড লাগে, আলটিমেটলি একই হাইট ফল করার জন্য পারফেক্টলি 2 সেকেন্ড সময়ই লাগবে। So total time লাগবে কত? Double of the calculated amount. বুঝছো কি? মানে ক্লিয়ার হইছে? আচ্ছা, আমি এখানে আরেকটা জিনিস তোমাদেরকে বলি, some of you might actually find this method to be quite complicated or a bit lengthy compared to this method. Obviously I agree with you, but one thing to be very clear, সেটা হচ্ছে if we are ever to calculate the time it takes for the stone to reach not back to the exact ground. Let's say if the question asked us, মনে করো এখানে আমাদের maximum height এর value আসছে 20 meter. I'm just going a bit overboard and trying to show you a different scenario for which this method would be the only way. So try to get at it. Let's say if the question asked us that calculate the time it takes for the stone to reach a height of, let's say, height of how much? Let's say 12 meters. So you just calculate the maximum height is 20 meter, which means 12 meter is below this level. Let's say if 20 meter is over here, so 12 meter would be somewhere around here maybe. So how much time would the stone require to reach to that level? So in this case, I'm not asking you to calculate the total amount of traveling time. I'm giving you a specific height and asking you to calculate the time relevant for that height. In this case, this method is your only go by way. You cannot use this mechanism anymore. The only reason this mechanism worked for us, because this was for the entire journey. So finding out the amount of time it requires to go up, we could calculate that easily, and then multiplying that amount of time by 2 actually worked for this question, because we are trying to find out the entire duration of traveling. But if you are not considering the scenario for the whole traveling distance, if you're considering any height in between, then this is your only go method. For example, if I solve this problem for you, this is how this equation is going to look like: s equals to ut plus half a t squared. So if I replace all the numbers over here, in this case we are going to go for 12 meter. So 12 equals to 20 into t plus half into minus 10 t squared. Do all of you clearly understand why a is placed as minus? Ulaban?
Sir, because the initial velocity is positive.
Beautiful. Because we have considered initial velocity positive, that's precisely why the acceleration has to be put at negative. আচ্ছা, আমি অ্যাডিশনালি আরেকটা জিনিস বলি, যেটা মাত্র মাথায় আসলো, সেটা হচ্ছে এই যে আমরা ইনিশিয়াল ভেলোসিটিকে পজিটিভ ধরার জন্য আমাদের অ্যাক্সিলারেশনকে নেগেটিভ ধরছি, এই অ্যাক্সিলারেশন, দিস ইজ অ্যাকচুয়ালি কনসিডার্ড মানে কনসিডার্ড ডিরেকশন ওরিয়েন্টেশন which is applicable for the entirety of the math. কেন বলতেছে এই জিনিস? স্টুডেন্ট অনেক সময় একটা জিনিস গড়বড় করে, সেটা হচ্ছে এরকম, আমি আরেকটা ফিগার রেখে দেখাই, এটা অলরেডি অনেকবার ওভাররাইট হয়ে গেছে। সেটা হচ্ছে, মনে করো অবজেক্টটাকে আমরা এখান থেকে শুট করছি, আমি ইনিশিয়াল ভেলোসিটি ধরলাম u ইকুয়ালস টু পজিটিভ 20 মিটার পার সেকেন্ড, এবং ওইটার জন্য আমি ধরলাম অ্যাক্সেলারেশন হচ্ছে মাইনাস 10 মিটার পার সেকেন্ড স্কয়ার। এখন মনে করো অবজেক্টটা অল দ্য ওয়ে ম্যাক্সিমাম হাইটে রিচ করলো, ম্যাক্সিমাম হাইট থেকে এখন সেটা আবার ফল ব্যাক করা শুরু করছে। শো দ্যাট উইথ ব্লু, লেটস সে স্টার্টিং টু ফল ডাউনওয়ার্ডস। আর আমার কোশ্চেন হচ্ছে, when the object is falling downwards, ওই সময় আমাদের এই ডাউনওয়ার্ড ভেলোসিটি আর অ্যাক্সেলারেশনের ডিরেকশন সেম না? ডাউনওয়ার্ড ভেলোসিটি আর ডাউনওয়ার্ড অ্যাক্সেলারেশন, এই দুটো ডিরেকশন সেম কিনা ফর দ্য ফলিং ডিউরেশন? These are same. So for that much motion, should I consider acceleration to be positive or not? I mean, can I do that, or should I do that? The answer to this question is you should not. If you do, it's gonna be a mess up and you are most likely to get wrong answers. I'll tell you why. Whenever the object is falling downwards, that duration of velocity, downward velocity downwards, should be represented as negative velocity. Acceleration is also negative. Automatically it implies that in this case negative velocity will be increasing by number because of the negative acceleration. Once you define a certain sign direction as your positive direction, you cannot switch it halfway in the math. That's gonna make a whole lot of mess of information. So many teacher might actually tell you that if the acceleration is working in the same direction of the initial velocity, we should consider both of them to be positive, which is okay, that works. But whenever you have reverted motion means in this case the object is going upwards, and right after that the object is also coming downwards. You have both direction of velocity working for your scenario within this question. So in this case, we should definitely consider one direction to be our positive direction and stick to that notion of direction, and define our vector quantities with respect to that. This is really important. So I'm going to get back to the mathematical operation over here. So ultimately we're going to get from this thing, we're going to get 5t squared minus 20t plus 12 equals to 0. Now this is a second order equation. You have to solve it by the second order formula. For those of you who know the formula, very beautiful, you can apply this and ready to go for it. This thing, I don't think this is gonna get into a good number of milliterm factor. I don't see it's happening by milliterm factor. So you have to go for that process, or maybe it's possible for milliterm factor. I don't know, I don't care. So if you know the quadratic equation formula that x equals to minus b plus or minus root over of b square minus 4ac divided by twice a, you can apply that. And additional to this, because you have access to calculators, which are really smart in equipments, if you know how to solve an equation using a calculator directly, you can directly do that as well. So you don't have to actually show anything over here. You can directly write two numbers over here. How many of you know how to solve an equation by calculator directly? Do you guys know how to solve it?
Yes.
Okay. For those of you who don't know it, look up on the web, on YouTube preferably. So the way you search is that solving an equation by calculator, Casio 991 ES, whatever your Casio model number is, and look up that video on YouTube and learn how to do that. So you have to go in the, you have to change the mode of the equation. You have to place the variables sequentially, and then only you can get the correct answer. So learn it from there. If I was physically present in front of you, I would like to show you, but to be honest, I cannot show you even by video camera because I still operate one of the black calculators, which are 100 or 850 ms. But you can use, I think all of you use natural display calculator. Am I correct? The silver ones or the white ones, right? So you have a grid display, which I don't use, but my calculator can do all the stuff that I need to do, and further is applicable for your level. So whatever the calculator model that you have, look it up in the YouTube and you can learn to solve this problem. So what I'm going to do, I'm going to put the variables within my calculator and come up with the answers directly. So give me some time. So t equals to 3.26 and the other one is 0.735. I'm writing the answers in 3SF. So I'm getting these two numbers. Now my question is to all of you, should we discard one from these two answers? And if we do, why? And if we don't, why? Think about it. The question was, what is the time when the stone is 12 meters above the ground? This is the question. If one of the time showed up to be negative, we would have definitely discarded that because time amount cannot be negative, which is just obviously. But here, both the time amounts are positive. So how about now?
So while going up, is it possible that we are counting one time for when the stone is going up and then another time for when it is going down?
Beautiful thinking and pretty accurate. Yes, precisely that's what's happening. Now, can someone tell me what is the time amount while the stone is going up and which one is for the going down?
So the bigger one is for the stone going up.
Sir, I think the opposite.
Yeah. Have a look. Try to understand. Kid, here's a stone. At the initial point of the journey, t equals to 0. It goes up, and we just calculated that the maximum height is reached at a time t equals to 2 seconds. ঠিক না? তার মানে কি? At 12 meter point এসে একবার থাকবে উপরে যাওয়ার সময়। এটা হবে 2 সেকেন্ড থেকে কম। দেন ফল করার সময় আরেকবার সে এই 12 মিটার হাইটটাকে ক্রস করে আসবে, ঠিক না? ওই টাইমটা হবে ফল করার সময় টাইমটা হবে 2 সেকেন্ড থেকে বেশি। এই 2 সেকেন্ডের রেফারেন্সটা কেন আসতেছি সেটা কি বুঝছো? 2 সেকেন্ডের রেফারেন্সটা জন্য যে একটা হচ্ছে মানে 0 থেকে 2 সেকেন্ড পর্যন্ত যতগুলো টাইমে আসুক না সবগুলো হচ্ছে রাইজিং টাইম, আর 2 থেকে 4 সেকেন্ড পর্যন্ত যতগুলো টাইম ক্যালকুলেট হবে সবগুলো হচ্ছে ফলিং টাইম। In other words, the smaller time is definitely for the upper going duration and the bigger time must be for the downward falling duration. So I'd say at t equals to 0.735 second, the stone is at 12 meter height going upwards, and at 3.26 second, the stone is at 12 meter height falling downwards. See if it makes sense.
Could you explain it again?
Yeah, sure. we just calculated that the time it takes for the stone to reach from the bottom all the way up to the maximum height is 2 seconds, right? Which means any time amount that we calculate out of the equation that is in between 0 to 2 seconds, this should fall for the rising time. Any time amount for 2 to 4 seconds should fall within the falling time. ঠিক না?
Yes, sir.
তাহলে আমার স্মলার টাইম ডিউরেশনটা হবে হচ্ছে কি রাইজিং টাইম, আর বিগার টাইম অ্যামাউন্টটা হবে কি falling.
Falling time.
So if you want to go, if you want to put your answer a bit more elaborately, usually not needed, but let's say the question asks you to, you could say that at t equals to 0.75 second, the stone is at 12-meter height from the ground going upwards, and at t equals to 3.26 second, the stone is at 12-meter height from the ground, above the ground, falling downwards. So this one is for the rising upwards, this one is for the falling downwards. This is how we can distinguish the two time values as well, but both of them are equally acceptable for this question. বুঝা গেছে সুলমান? মানে ক্লিয়ার কিনা এই পর্যন্ত?
স্যার একটা ভ্যালু নেগেটিভ থাকলে কি হতো?
বুঝিনি, আর বলো।
স্যার একটা ভ্যালু নেগেটিভ থাকলে কি হতো?
একটা ভ্যালু নেগেটিভ আসলে সেটা নেওয়া যেত না। কেন নেওয়া যেত না সেটা আমি তোমাকে একটু পরে আমি আরেকটা কোশ্চেন দিয়ে তোমাকে এক্সপ্লেইন করতেছি। Time cannot be negative because any calculated time cannot be negative unless you are really working with relativistic time. Time cannot be negative because time is one of those variables or one of those you can say dimension which is always perceived to move forward. আচ্ছা, আমি কি ধরনের কেসে টাইম ক্যালকুলেশন নেগেটিভ আসতে পারে সেটা একটা एग्जांपल দেখাই। Actually, আমি একটা প্রবলেম সলভ করতেছি. Some of you might feel like the discuss is going pretty slow. I am still stuck in question number 1b. But what I'm trying to show you is that what are the different type of variations you can have and how the different equations can be applied for different scenarios and what could different amount of time measurement could actually mean. Although these questions are not exactly in question number 1, but I'm trying to show you the possible variations that we might actually come across. So I earnestly request you not to get bored. Maybe you know these stuffs already, which is very nice. It's a quick brush up for the upcoming part of our class. So please stay tuned. A different example, let's say I'm going to use the same variables. So 20 meter per second is going to still remain 20 meter per second. Let's say there is a cliff beside sea. So let's say this is the sea surface. Okay. So let's say there is a person, stickman, shooting the stone upwards from the very edge of the cliff. Drawing a stickman actually makes up the figure pretty unworkable. So let's say the stone is over here, is going to be shot upwards. So the initial velocity is considered u equals to 20 meter per second, and eventually the stone is going to fall all the way down into the ocean. Let's say the question already tells you that the height of the cliff from above the ocean level is 30 meter. কথা বুঝো, height of the cliff from above, this is the cliff, the stone mountain, and this is the water. So the height of the sea above the cliff is 30 meter. Now let's say they ask you that calculate the time it takes for the stone fall onto the ocean from the time it is thrown. So throw করা থেকে শুরু করে ওশনে পড়া পর্যন্ত টাইম বের করতে বলছে। এখন এখানে কি কি ভুল হতে পারে এবং কেন সেই ভুলগুলো হতে পারে সেগুলো সহ আমি পুরো জিনিসটা বুঝাচ্ছি। এই কোশ্চেনের প্রিমিসটা বুঝা গেছে কিনা সবার? মানে এখানে আমরা কি করতে যাচ্ছি সেটা বুঝা গেছে কিনা বলো মান? The information that is available to you, এই ইনফরমেশনটুকু বুঝা গেছে কিনা?
Could you explain again?
We have a stone that is being thrown upwards at 20 meter per second from the side of a cliff, which is going to go upwards and eventually it's going to fall into the sea. The sea level is exactly 30 meter below the level of the cliff, or the question could also say that the cliff level is 30 meter higher than the level of the sea. Either way, it's the same thing. The question is asking you that what is the time for the stone to hit the water? What is the time for the stone to hit the water? I think I'm using too many articles. Anyway, so টোটাল কতটুকু সময় পরে এসে স্টোনটা পানিতে পড়বে এটা আমাদেরকে ক্যালকুলেট করতে বলছে। তখন আমরা এই প্রবলেমটা কিভাবে সলভ করব? এটা সলভ করার অনেকগুলো উপায় আছে, শর্টকাট উপায় আছে, লং উপায়ও আছে। আচ্ছা, আমি তোমাদেরকে ডিফারেন্ট কয়েকটা অ্যাপ্রোচ দেখাচ্ছি। এক নাম্বার হচ্ছে I'm going to show you the simplest of the straightforward approach which uses a bit of understanding for vector. In the case of motion, we considered for the case of this motion, for all the earlier examples, we considered upward direction as positive. This upward direction positive is applicable for all the vector quantities that we're talking about. So it is applicable for velocity, it is applicable for acceleration. Needless to say, it will be equally applicable for displacement as well, which is also a vector quantity. Now try to understand, this is our throwing off level, this is our shooting level, okay, which means a লেভেলের এই হরাইজন্টাল লেভেলের উপরের যে কোনো ডিসপ্লেসমেন্ট হবে পজিটিভ ডিসপ্লেসমেন্ট, ঠিক না? এই লেভেলের নিচের যে কোনো পার্টের ডিসপ্লেসমেন্ট হবে কি? নেগেটিভ ডিসপ্লেসমেন্ট হওয়ার কথা না? থিংক অ্যাবাউট ইট ফর দ্য কোঅর্ডিনেট সিস্টেম। যখন আমরা কোনো একটা সার্টেন গ্রাফ প্লট করি, লেটস সে ইউ হ্যাভ এক্স অ্যাক্সিস এন্ড ওয়াই অ্যাক্সিস, এই অরিজিন পয়েন্টের উপরে ওয়াই অ্যাক্সিসের সব ভ্যালুগুলো হচ্ছে কি পজিটিভ না? যখন আমরা নিচে চলে যাবো তখন আমাদের ভ্যালুগুলো কি চলে আসবে? সবগুলো নেগেটিভ চলে আসবে না? Think about it. Displacement is basically what? The linear distance from the initial position of the object to the final position of the object. Actually the other way around, but that's basically the idea of displacement. So why am I telling you this? What you need to understand, when the stone will hit the water, where would the stone be? So if I try to draw the path of the stone with a little bit of curve, because I don't want the stone to hit back onto the cliff. Let's say the stone rises up this much and it takes a little bit of curve for whatever reason, and eventually it falls all the way down vertically to the sea. So this is the total traveling of this thing. So it rises up a shorter height because it was above the cliff, and then it goes beyond past the throw level and eventually goes further down and eventually hits the sea. So my question to you, do you physically understand that considering upwards as a positive direction, any displacement above the starting point should be positive, any displacement below the starting point should be negative? এই জিনিসটা বুঝা যাচ্ছে কিনা?
Yes, sir.
Because this starting point is basically our starting point. So আমি যদি এই পয়েন্টের ডিসপ্লেসমেন্ট চিন্তা করি তাহলে আমার অ্যাকচুয়াল ডিসপ্লেসমেন্ট হচ্ছে কতটুকু? আমি অন্য একটা কালার ইউজ করি, লেটস সে I'm going to use black. If I want to visualize this, এই পয়েন্টের ডিসপ্লেসমেন্ট সেটা হচ্ছে এই পয়েন্ট থেকে এই দিকে and eventually the arrow is going to be this way. আমি যদি এই পয়েন্টের ডিসপ্লেসমেন্ট জাজ করি তাহলে সেটা হবে এখান থেকে এই পর্যন্ত and the arrow is going to be this way. Actually these lines should overlap onto each other, but disregard that fact. But your displacement should be always drawn from the starting point to the final point. Vice versa, if I want to represent the displacement at, let's say, in this point, I should start from the starting point and draw the vector downward, right? So the downward displacement vector should be definitely a what? Negative vector, ঠিক কিনা? এই জিনিসটা convincing, মানে are you convinced about this? It's important that you perceive this in a logical manner. Just don't take my word for granted. I mean, why downward displacement should be negative beyond the point of throw? এটা কেন হবে? By a vector quantity, you should understand that. এটা বুঝা গেছে কিনা?
Yes, sir.
Any question, anyone? So let me just rub off this thing because I want to use this space for writing. So let me just keep the whole figure on all left so that we can actually have a little bit of visualization, and I'm gonna put this question right on top so that I can use this space as well. So selecting it all, moving it there. So the straightforward way to solve this problem is that I'm gonna write all the available information. We know that in this case u equals to 20 meters per second and a equals to Should I go for a different number? Because you might actually try to perceive it by from earlier question. Should I go for a different number? I feel I should go for a different number. Or not? No, no. Let's do it by the same number. So this is the two information that we already know. Initial velocity upward 20 meter per second, acceleration downward minus 10 meter per second squared. The question is asking us to find out the time. What is the amount of time when the displacement is going to be minus 30 meter? Now this is the choice that is new for you. That writing a displacement to be negative. Remember, I'm writing the value of a displacement, which is a vector quantity. So it can be positive or negative both. In the very same way, acceleration is a vector quantity, displacement is also a vector quantity, velocity is a vector quantity, displacement is also a vector quantity. So falling below the starting point, the displacement vector is supposed to aim downwards, which gives me a negative number. If you can understand this much, the whole problem becomes far too simpler. We can just now replace all the numbers over here and get it over with. So have a look. S equals to ut plus half a t squared. So I'm going to write minus 30 equals to 20 into time plus half into minus 10 t squared. So what I'm going to get ultimately is 5t squared minus 20t minus 30 equals to 0. Dividing all sides by 5, I'm going to get t square minus 4t minus 6 equals to 0. And এই কোশ্চেনটা সলভ করে দেখো কত আসে। দেখো এরকম দুটো নাম্বার আসছে কিনা।
Yes, sir.
ওকে, সো এই যে আমরা একটা নেগেটিভ টাইম পেলাম, এখন এই নেগেটিভ টাইমটা মানে কি? অবভিয়াসলি নেগেটিভ টাইম মিন্স এটা আমাদের ইকুয়েশন থেকে বাদ যাবে, বাট is there a physical significance that is important of this number? Well, for your syllabus volume, we just simply discard it by saying negative time is not possible, so not going to happen. But I'm going to give you a little bit of insight for you, some thought candy or something to think about. You can totally choose not to think about it, but the idea is that here's the deal. We shot the stone. Try to understand what I'm saying. I'm not gonna repeat this much because it's not within a syllabus, so I don't want to bother everyone who is not interested. The idea is that we consider t equals to 0 when the stone was at this level going upwards at a velocity of 20 meter per second. This was our starting point. Now, if this motion was actually achieved by a continued motion from earlier, for example, আমি যদি একটা স্টোনকে মনে করো আরো ফার্দার নিচে লেভেল থেকে 30 মিটার পার সেকেন্ড স্পিডের উপরে থ্রো করতাম, তাহলে সেটা আস্তে আস্তে ডিসিলেট করতে করতে কোনো না কোনো পয়েন্টে 20 মিটার পার সেকেন্ড স্পিড গেইন করতে পারতো কিনা? পসিবল না? Our math said that at the initial time at t equals to 0 second, the initial velocity of the stone upward was 20 meter per second. If we try to visualize that this 20 meter per second speed was not the initial velocity, rather it was gradually gained from a bit earlier. So that would mean maybe the stone was traveling from underneath and slowly was rising up, and exactly at this point it reached this 20 meter per second. This time actually means that if this speed was achieved by continuous motion, so if we consider this as if this was t equals to 0 And if we could possibly look back in time with the same acceleration value at t equals to minus 1.16 second, the stone would have been at this level. তার মানে হচ্ছে আমি যদি এই মানে this actually means that if I shot the stone from this level vertically upwards at minus t equals to 1.16 second, it would take 1.16 second for the stone to rise up to this level and reach a speed of 20 meters per second. And then the remaining of the motion could be continued, and that's basically a way to represent that the motion could also be represented as if it was going the other way around in the time axis, but which is not a very practical thing, at least not for your level. It requires quite a lot of relativity, so we can simply discard this number just by saying that because time cannot be negative, we do not accept this, so the correct answer is this. এই ম্যাথটার ওয়ার্কিং বুঝা গেছে কিনা বলাপান? If you didn't understand what is the physical significance of this number, you don't have to bother, forget about that. But how this whole math worked out, this whole part, এই পার্টটুকু ক্লিয়ার হয়েছে কিনা? I think so. If you have any question, please ask. The next thing that is the next way, or the different other way that I want you kids to try is try to find out the time it takes for the stone to fall only through this much distance. So I'm asking you to calculate something on your own. আমরা একটু আগে ক্যালকুলেট করছি, আগের কোশ্চেন থেকে অলরেডি আমরা ক্যালকুলেট করে আসছি যে এই হাইট থেকে উঠে এক্স্যাক্টলি এই হাইটে পারফেক্টলি ফল করার জন্য টোটাল কত সেকেন্ড টাইম লাগবে? 4 সেকেন্ড টাইম লাগবে। এটা আমরা ক্যালকুলেট করছি না একটু আগে? বলুন বুঝো। This was for the earlier problem that we threw a stone off the ground at 20 meters per second, went all the way to the highest level, eventually fell to the same level on the ground. So how much time did we take? 4 seconds, right? তার মানে হচ্ছে আমি যদি ক্লিফের উপর থেকে এখান থেকে যদি স্টোনটাকে 20 meters per second upward speed থ্রো করি, this stone is going to go up and eventually fall down, and exactly after 4 seconds it's going to come at the same level. It's going to come at the exact same level. এবং এক্স্যাক্টলি এই সেম লেভেলে তার ডাউনওয়ার্ড স্পিড কত হওয়ার কথা এটা একটু চিন্তা করো তো। What would be the downward speed as it is at the same level of the cliff falling downwards? What do you think? Other than doing any calculation.
50 meters per second.
It should be also 20 meters per second. If you wonder why, the idea is very simple. Try to understand. I can actually give you a lot of different way to show this, but one simple way to show this is this. Have a look. This is VT graph, right? Let's say your initial velocity was 20 meters per second upward at t equals to 0. It is decreasing by virtue of gravitational acceleration. When it becomes 0, it is the maximum height. It takes how much time to reach maximum height? 2 seconds. Then it should fall another 2.0 seconds to reach the bottom, which means it should take 4.0 seconds to reach to the bottom. Now, because these two areas have to be equal, এই দুটো এরিয়া ইকুয়াল হতে হবে না, কারণ এটুকু হচ্ছে রাইজ আর এটুকু হচ্ছে ফল। তার মানে এসেনশিয়ালি আমার এই ভ্যালুটা পারফেক্টলি কত হতে হবে? এই ভ্যালুর সমান হতে হবে না? Do you understand this logically? That because air resistance is not involved, the rate of speed at which the speed decreases as the object goes up, as the object falls down, it is going to gain speed at the same exact rate, because same acceleration, minus 10 per meter per second square, is working on it. As the object is going up, it is losing 10 meters per second per second. So every second it is losing 10 meters per second. That's why 20 meters per second totally lose করতে আমাদের টোটাল কত সেকেন্ড টাইম লাগতেছে? 2 সেকেন্ড টাইম লাগতেছে। মানে after 1 second its speed is going to be 10 meters per second, after another second its speed is going to be 0 meters per second. So এখন যখন সে ফার্দার ফল ডাউন করবে, ফল করার সময়ও তার টোটাল টাইম লাগছে কত সেকেন্ড? 2 সেকেন্ড। তার মানে after 1 second is going to be 10 meters per second downwards, after another second is going to be 20 meters per second downwards. So this is a basic idea of symmetry. So which means when the stone is going to be when the stone is falling and it is at the same level with the cliff, it is at the same level as with the cliff, the downward speed is going to be, let me write it red, 20 meters per second. I want you kids to try and find out how much time is going to be needed for the stone to fall from this point to touch the cliff. এই টাইমটুকু একটু হিসাব করে বাই করো। I'll give you some time. Be right back. কোনটা এখানে মাইনাস কেন আসছে?
Yes, sir.
এখানে মাইনাস আসছে জাস্ট ক্যালকুলেশন থেকে। তোমার যেটা বোঝা দরকার, মানে হোয়াট ইজ ইম্পর্টেন্ট ফর ইউ টু আন্ডারস্ট্যান্ড ইজ দ্যাট হোয়াট ইউ আর গোনা রিপ্লেস, যে এস এর ভ্যালু কেন মাইনাস বসাইলাম, ইউ এর ভ্যালু কেন মাইনাস বসাইলাম, এর ভ্যালু কেন মাইনাস বসাইলাম, এই তিনটা জিনিস বুঝছো কিনা?
Yes, sir. ওটাই question ছিল।
আচ্ছা, এস এর ভ্যালু মাইনাস কারণ হচ্ছে for this part I'm trying to figure out that the object is starting from here, falling downwards, which is the negative direction because I considered upward as positive. So downward fall করতেছে 30 meter, so তার displacement হচ্ছে -30 meter, এই জন্য ডিসপ্লেসমেন্টটা -30 বসাইছি। Initial velocity was also downward, 20 meter per second, so that's why I placed -20, and acceleration is still working downwards, so -10. So all the vector quantities in this case are working in the negative direction, that's why I placed all the numbers as minus. If you want to place everything in this equation as positive numbers, your equation is still going to work out and you're going to get the same exact values over here as well. But I want you to understand why they should be placed at minus in accordance to the idea that we considered upward as positive direction for the vector quantities. আমি যদি সবগুলো নাম্বার এখানে পজিটিভ বসাতাম তাও আমার ম্যাথটা পারফেক্টলি ওয়ার্ক করতে, you're going to end up with the same exact equation and it would work just fine, no big deal. But I want you to understand কেন আমি মাইনাস বসাচ্ছি সেই জিনিসটা আমি বোঝানোর চেষ্টা করতেছি। বুঝছো কি?
Yes, sir. Thank you, sir.
No problem.
Sir, I had a question.
Please go ahead.
Sir, if we follow this method, like sir, যদি আমরা হলো যে কোনো অবজেক্টের নিচে পড়ে ওটার ভ্যালু যদি আমরা মাইনাস দিয়ে দিই, তাহলে কি স্যার ইজ ইট পসিবল যে হলো আমরা অ্যাক্সিলারেশন ডিউ টু গ্র্যাভিটি অলওয়েজ মাইনাসে রাখতে পারবো?
Yes, for all the motion cases, acceleration due to gravity can be used as a negative vector, provided you consider upward direction, all upward vectors as positive and all downward vectors as negative. ওই জাজমেন্টে তুমি এটা পারফেক্টলি ফলো করতে পারবা, and this will give you a much simpler way to solve the problems.
Thank you.
I mean, এই কেসে এই প্রবলেমের জন্য তোমাদের কাছে জিনিসটা হয়তো একটু কমপ্লিকেটেড লাগছে because the actual size of the question is quite small, but these questions can be actually made into a much more complicated stuff. For example, you can actually have a question that have 4 or 5 different parts to carry out. So you have initially a certain scenario, then something else happens, and then sometimes the object bounce off the ground and eventually starts to bounce upwards. We have to calculate the motion for that part as well. So if you have a continued motion for a significantly larger size of premise, in that case it's considering a single direction as positive and placing all the numerical values of the vector quantities in accordance with that direction that you considered initially will save you a lot of effort and time. তোমাকে প্রত্যেকটা ইকুয়েশন আলাদা আলাদা করে জাজ করতে হবে না, তুমি নরমালি ভ্যালু বসায় যাবা, অটোমেটিক্যালি ইকুয়েশন তোমার আনসার গুলাকে তোমার দিয়ে দিবে। Does it make sense?
Question.
হ্যাঁ বলো।
Sir, instead of like this question, যেখানে স্যার ডাইরেক্টলি নিচে পড়ছে displacement is 30 meters, but sir যদি উপরে ভাবেন যে হলো আরো 10 মিটার আছে, তাহলে কি স্যার আমরা 30 থেকে -10 করব and minus?
I mean, you're asking that what if there was another boat, let's say that is 10 meter tall and the stone fell over here, এরকম?
No sir, I mean like before it falls from the cliff, মানে স্যার ক্লিফ যেখানে আছে ওখানে সাইডে হয়তো আরেকটা ল্যান্ড আছে, তাহলে যে ওইখানে শুরুটা পড়েছে তারপর আবার নিচে পড়া শুরু করেছে, তাহলে like bounced off, তাহলে?
Oh, so you're asking that what if the stone goes up, then comes down to the cliff and then falls over here and then bounce off back onto the seafloor, এরকম?
Yes sir.
Well, if that happens, then this part of the motion, as long as when the stone will collide with the ground, is going to lose some kinetic energy because of the collision process. So ওই পার্টটুকুর হিসাব হবে আলাদা, মানে হচ্ছে আমাদের উপর থেকে উপরে উঠে নিচে বাউন্সিং আগ পর্যন্ত পুরো মোশনটা হচ্ছে ক্লিফের উপরে। সো এই পার্টের জন্য আমাদের ডিসপ্লেসমেন্ট নেগেটিভ হওয়ার কোনো কারণ নাই, কারণ অবজেক্ট এখনো পর্যন্ত নিচে পড়ে নাই, মানে আমাদের শুটিং পয়েন্টের বা স্টার্টিং পয়েন্টের বা কনস্ট্যান্ট
30 মিটার মানে কোন ডিফারেন্স আসবে না, ডিসপ্লেসমেন্ট -30 থাকবে
না, হ্যাঁ ডিসপ্লেসমেন্ট -30 থাকবে। এটা মনে রাখা সবচেয়ে ইজি বুদ্ধি হচ্ছে আমি যেটা একটু আগে দেখালাম, যে ইফ ইউ কনসিডার দ্য কোঅর্ডিনেট সিস্টেম অফ এ সার্টেন এক্সিস সিস্টেম, y axis এর অরিজিনের নিচে সবগুলো পয়েন্ট কি হয়, নেগেটিভ হয় না? সো আমরা একটা মুভিং অবজেক্টের জন্য তার স্টার্টিং পজিশন মানে দ্য লোকেশন এট টি ইকুয়ালস টু 0 ওইটাকে আমরা তার ডিসপ্লেসমেন্টের অরিজিন হিসেবে ধরে নেই। So if the object is moving upward above that level, we consider that positive displacement. If the object is falling below that level, we consider that as negative displacement. That is the basic idea. So object অনেক মনে করো let's say for an example, this was not a stone. Let's say this was an RC helicopter for all I care. ঠিক আছে, এই আরসি হেলিকপ্টার মনে করো এখান থেকে কেউ চালাই দিচ্ছে, এখানে এসে আরসি হেলিকপ্টার পুরো দুনিয়া ঘুরে এসে ইভেন্চুয়ালি কোনো এক সময় ব্যাটারি শেষ হয়ে গেছে, সে এখানে এসে সিতে পড়ছে। And আমাকে যদি displacement for some part of the math, if I have to use the displacement of the RC helicopter starting from this point to this point, vertical displacement, I still have to use -30 irrespective of the path. I think that answers your question. বুঝছো? Beautiful. RC helicopter মানে তো বুঝো?
Radio control helicopter.
Beautiful, precisely, or remote control helicopter. It might be also by microwave, but anyway, yeah. So that was a pretty elaborate discussion, which we actually drifted away from 1B. So if we have a look at 1C, 1C says the distance covered if initial speed was doubled. So total distance covered for, I'm coming back to the same question. So forget about the cliff question. Now we're coming back to the same question, that the stone was thrown from the ground, coming back all the way ground. The question is asking us the total distance covered if initial speed was doubled. এই টাইপের কোশ্চেন সলভ করার একটা ইলাবোরেট মেথড আছে, একটা শর্টকাট মেথড আছে। আমি শর্টকাট মেথডটা বোঝানোর জন্য তোমাদের কয়েকটা প্রপোর্শনালিটি দেখাই, এই জিনিসটা খেয়াল করো। We had 4 equations of motion. Let me write those once again. Number 1 was v equals to u plus at. Number 2, s equals to u plus b divided by 2 into t. Number 3, s equals to ut plus half at squared. And number 4, v square equals to u square plus twice as. Now, one thing that I need you to understand, তোমরা ম্যাথে হয়তো proportionality পড়ছো. Let's say if I go for a certain two variables, any two variables, let's say if it's defined that variable p is proportional to variable q, this is what we call a proportionality, direct proportionality, that is. এই direct proportionality কে যদি আমরা একটা ইকুয়েশনে কনভার্ট করতে চাই, we bring about a proportionality constant k over here to make it into an equation. এই k ইকুয়েশনটাকে, এই k এর প্রপার্টিটা হচ্ছে যে আমি যদি p বাই q রেশিও করি, তাহলে সেই রেশিওটা সবসময় এই k এর সমান হবে। তার মানে হচ্ছে আমার যদি p এবং q এর অনেকগুলো ডিফারেন্ট পেয়ার ভ্যালু থাকে, লেটস সে I have for a certain value of p1 I have a relevant value of q1, এই রেশিওটার ভ্যালুও k হবে। আমার যদি p2 by q2 করি, সেই রেশিওটার ভ্যালু k হবে। তার মানে প্র্যাকটিক্যালি if I have multiple different pair values of p1 and pq1, p and q, p1 by q1 equals to p2 by q2 equals to p3 by q3 equals to dot 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 dot. I can place all the individual pair values of p and q. I mean, let's say you have one value of p and a relevant value of q. The ratio of those two numbers would always give you this quantity. That's what we mean by the idea of proportionality, which means they are proportional to each other. It means their magnitudes are related by a specific multiplier. যেমন একটা ইকুয়েশন তুমি যদি চিন্তা করো যে লেটস সে একটা নিউমেরিক্যাল ইকুয়েশন y equals to 2x, y equals to 2x, এই ইকুয়েশনের মানে হচ্ছে যে আমরা এই y equals to 2x আমাদেরকে যে স্ট্রেট লাইনটা দিবে, তোমরা তো স্ট্রেট লাইন বুঝো, এটা যে y equals to mx স্ট্রেট লাইন, এটা বুঝো? মানে স্ট্রেট লাইন ইকুয়েশন তোমরা পড়ছো ম্যাথে yet? y equals to mx or y equals to mx plus c, এগুলো পড়ছো? You can say no, it's okay, I'll teach you.
অর্ধেকটা করানো হয়েছিল।
Acha, this is the equation y equals to mx, which is basically a straight line that passes through the origin without any y axis or x axis intercept. এই ইকুয়েশনটার মানে কি? এই ইকুয়েশনের মানে হচ্ছে y divided by x, এই রেশিওটা সবসময় হবে 2। তার মানে তুমি একটা এই লাইনটাকে প্লট করলে, মনে করা হচ্ছে আমি y equals to 2x যদি প্লট করি, এটার মানে হচ্ছে এই লাইনটা প্লটিং কিরকম হওয়ার কথা? এই লাইনটা প্লটিং হওয়ার কথা হচ্ছে এরকম। মনে করো এখানে হচ্ছে x equals to 1 হলে y এর ভ্যালু হবে হচ্ছে 2। সো আমার 0 0 তে একটা পয়েন্ট আসবে, 1 2 তে একটা পয়েন্ট আসবে, 2 4 এ একটা পয়েন্ট আসবে, তারপর 3 6 এ একটা পয়েন্ট আসবে, আমার সবগুলো কোঅর্ডিনেট এইভাবে চেঞ্জ হতে থাকবে। সো আমি ইন্টিজার নাম্বার দিয়ে দেখাইলাম, বাট আমি যদি কোনো মাঝখানে ফ্র্যাকশন নাম্বার ধরি সেগুলো ধরতে পারতাম। বাট দ্য আইডিয়া ইজ এই স্ট্রেট লাইনের উপর যতগুলো পয়েন্ট থাকবে সবগুলো পয়েন্টের কোঅর্ডিনেট এরকম হবে যে y এক্সিস ভ্যালু ডিভাইড বাই x এক্সিস ভ্যালু, এই রেশিওটা সবসময় তোমাকে কত দিবে? 2 দিবে। That's basically what we mean by the concept of proportionality. That's why we have a straight line equation, because the numbers would be multiplied by a fixed amount, which we call the proportionality constant. কেন বলতেছি এই কথাগুলো? এই জন্য বলার কথা যে if we have a proportionality relationship like that, automatically এই ধরনের proportionality relationship থেকে এই ধরনের ইকুয়েশন বিল্ড আপ করা যায়। p1 by q1 equals to p2 by q2, or if you have more pair values, p3 by q3, এই ধরনের proportionality বিল্ড আপ করা যায়। This always agrees with the given proportionality. এটা হচ্ছে একটা ইনফরমেশন। The second information is that একটা ইকুয়েশন যদি এরকম হয়, একটা ইকুয়েশন একটা সার্টেন কোয়ান্টিটিকে যদি আমরা কনস্ট্যান্ট হিসেবে অলরেডি ডিফাইন করতে পারি, হিয়ার মি আউট, একটা সার্টেন ইকুয়েশনের একটা সার্টেন মেজারমেন্টকে যদি আমরা কনস্ট্যান্ট হিসেবে ডিফাইন করি, সেই কনস্ট্যান্টটাকে উঠায় ফেললে, if I take this constant out, we can convert the equation into a proportionality as well. In the same way, a proportionality can be converted into an equation. By getting rid of the constant, we can make an equation into a proportionality as well. এই প্রসেসটাও লজিক্যালি অ্যাচিভেবল। সো এটা বলার মেইন রিজনটা হচ্ছে যে এখানে আমাদের দেখো টোটাল 4টা ইকুয়েশন আছে, b equals to u plus at, s equals to plus v by 2, s equals to 2 plus half a square, b square equals to u square plus twice s. One of the key requirement for this equation to be valid or to be usable under given circumstances was that acceleration has to be a constant. We can only apply these equations for segments of motion where acceleration of the object is not changing. Acceleration of the object is not changing. Now, how does that work? How does that work? এই জিনিসটার উপর বেস করে, সো আমরা not how does that work, I mean what we're going to do with this information. এই 4টা ইকুয়েশনের মধ্যে যেই 3টা ইকুয়েশনে অ্যাক্সেলারেশন আছে, সো উইদাউট দিস ওয়ান, এখানে অ্যাক্সেলারেশন আছে, এখানে অ্যাক্সেলারেশন আছে, এখানে অ্যাক্সেলারেশন আছে, আমরা অ্যাপ্রোপ্রিয়েট কিছু অ্যাডিশনাল সিচুয়েশন অ্যাড করে আমরা এগুলো থেকে কিছু প্রপোর্শনালিটি বাই করব। প্রপোর্শনালিটি গুলো কিরকম সেগুলো একটু আমরা খেয়াল করার চেষ্টা করি। মনে করো লেটস সে ইফ আই গো ফর ইকুয়েশন নাম্বার 1, ইকুয়েশন নাম্বার 1 হচ্ছে v equals to u plus at. মনে করো একটা সিচুয়েশন হচ্ছে এরকম, an object was starting from rest. Starting from rest এর মানে কি? u equals to 0, ঠিক না? বলো 1. Starting from rest means initial velocity 0. This will give me v equals to at. If I take the a as a constant and want to take it out of the equation, I can rewrite this relationship as final velocity would be directly proportional to time. এই কনভার্সনটা বোঝা যাচ্ছে কিনা, এই 3টা লাইন বোঝা যাচ্ছে কিনা? Under the logic, I'm going to write if u equals to 0, then v equals to at, which gives us the proportionality v proportionality. তার মানে হচ্ছে, I mean, how can I describe this proportionality in words? I can say if an object starting from rest undergoes uniform acceleration, কথাগুলো খেয়াল করো, if an object starting from rest undergoes uniform acceleration, its final velocity will always be directly proportional with the duration of travel. I'll say it again. If an object starting from rest undergoes uniform acceleration, its final velocity will always be directly proportional, or you can just say its final velocity is directly proportional to the duration of travel or to the time. আইডিয়াটা কি বোঝা যাচ্ছে কি করলাম এখানে? বলবান। এখন এই সিচুয়েশনটার মানে এই প্রপোর্শনালিটি ইউজফুলনেস কিরকম হতে পারে? ইউজফুলনেস হচ্ছে এরকম, if an object starts from rest, for all of its motion situation we can have that kind of a proportionality. For example, we can write v1 by t1 should be equals to v2 by t2, or should be equals to v3 by t3, or even further. So if in any case you are provided with one time amount with another final velocity, you can easily find out the final velocity for another time amount. এই টাইপের যে প্রপোর্শনালিটি ইকুয়েশনগুলো অনেক টাইপের ইউজ আছে, সেই ইউজগুলো আমি ওয়ান সিতে তোমাদেরকে দেখাবো। এটা হচ্ছে একটা পার্ট। সেকেন্ড লজিক হচ্ছে এখানে আমি ধরছিলাম হচ্ছে ইনিশিয়াল ভেলোসিটি 0. So what if in a certain scenario final velocity is 0? Now you need to ask yourselves, if we define an object's final velocity is to be 0 where we have a non-zero acceleration, what type of acceleration are we talking about? Are we talking about speeding up or are we talking about slowing down? If an object after a certain amount of movement reaches a final zero velocity, then what type of motion are we talking about?
Constant.
I mean, are we talking about slowing down or are we talking about speeding up?
Slowing down.
If the final velocity of a certain motion is to be 0, then we should be definitely going for a slowing down scenario, right? So এখন slowing down scenario মানে হচ্ছে আমাদের এই অ্যাক্সেলারেশনটার ডিরেকশন ইনিশিয়াল ভেলোসিটির উল্টা দিকে। এই কথাটার এই ফাইনাল ভেলোসিটি 0 কথাটার ইমপ্লিকেশন হচ্ছে এরকম, let's say we had an object which was going let's say in one direction at an initial velocity of u, and an opposite acceleration a was working on the object in the opposite direction. I cannot show this acceleration over here because this I have to draw over the entire period, but this acceleration was working in the opposite direction, which means this was a case of uniform deceleration. And as a result, after a certain amount of time, ultimately the object reached final velocity 0. This is the scenario. So final velocity 0 হতে হলে আমাদের initial velocity একটা ভ্যালু থাকতে হবে, and we have to have a constant deceleration. Deceleration means negative acceleration. So এই কেসে আমি লিখতে পারি if v equals to 0, so if the final velocity have to 0, then I can write 0 equals to u minus at. এই প্লাসটা কেন মাইনাস হয়ে গেল, এই লজিকটা কি বুঝা গেছে কিনা বলবান? ইকুয়েশনে v equals to u plus at ছিল, বাট এখানে আমি v টাকে 0 বসাইছি আর একই সাথে a টাকে আমি মাইনাস লিখে দিছি। কেন মাইনাস লিখছি এটা কি বুঝা গেছে কিনা? আচ্ছা এটা কি
আবার
বুঝাচ্ছি। তুমি একটা জিনিস চিন্তা করো, নরমালি মনে করো একটা অবজেক্ট মুভ করতেছে এবং আমি তোমাকে বলে দিলাম যে এই অবজেক্টটা মুভ করতেছে এমন ভাবে ইভেন্চুয়ালি এই অবজেক্টটা ফাইনাল ভেলোসিটি 0 হবে। সো initially the object was moving and the final velocity has to be 0. So essentially I'm trying to give you a situation where the object is slowing down. এটা তো ক্লিয়ার, ঠিক আছে? And if an object is slowing down, essentially the acceleration of that object, is it working in the same direction of the initial velocity or is it working in the opposite direction of the initial velocity? I mean, are we talking about deceleration or slowing down, or are we talking about actual acceleration or speeding up? What should be the acceleration be? Isn't it obvious that for a slowing down case, the acceleration should be in the opposite direction of the initial velocity? That way, the object would actually decelerate, or it is going to slow down at a uniform rate and eventually can reach a final 0 velocity. That's precisely what I'm trying to show you over here, that initial velocity is working, let's say, from left to right, object is traveling from left to right, but the acceleration is working in the opposite direction, which is basically working as a deceleration, so that the object can finally reach to a final 0 velocity. This is why the direction of u is placed as positive and the acceleration direction was placed as a negative, because as vectors, these two vector quantities, initial velocity and acceleration, for this situation must work in opposite direction. That's what I'm trying to get at. বুঝাচ্ছে? Zara, Mustahsin, বুঝাচ্ছে?
জি স্যার।
Yes, sir.
Okay, if you have question, please respond. I'll help you understand. I'll try to come up with different example maybe. So if we have this equation over here, we can also write that in this case u equals to at, and that brings us to the proportionality. That should be u proportional to taking the acceleration, constant acceleration out of the equation. We can get this proportionality over here, which can give us this part, u1 by t1 equals to u2 by t2 equals to u3 by t3 equals to t3. আচ্ছা, তোমাদের হয়তো এই ইকুয়েশনটার সিগনিফিকেন্স বুঝতে সমস্যা হতে পারে। আমি এই যে ইকুয়েশনগুলো লিখতেছি, এই ইকুয়েশনগুলোর ফিজিক্যাল কিছু সিগনিফিকেন্স তোমাদেরকে দেখায়, মানে ড্রয়িং করে দেখাচ্ছি যাতে করে তোমরা ভিজুয়ালাইজ করতে পারো। Should I do that? I can totally do that. I think I should do that because I want you guys to be able to understand physically what it means. আচ্ছা আমি প্রথমে এটার জন্য দেখাচ্ছি আই এম ট্রাইং টু শো দিস ফর দ্য ফার্স্ট টাইম ফর দিস থিং সো আই এম গোইং ব্যাক টু দ্য ফার্স্ট স্টোরি দ্যাট ইফ ইনিশিয়াল ভেলোসিটি ওয়াজ 0 এই সিচুয়েশনটার মানে হচ্ছে লেট মি জাস্ট ড্র ইট ওভার হিয়ার an object was initially at rest অবজেক্টের উপর আমরা a acceleration let's say towards right অ্যাপ্লাই করব তাহলে অবজেক্ট ওভার দ্য টাইম আস্তে আস্তে স্পিড আপ করবে ঠিক না at the initial time when u equals to 0 this is the time where we are starting our time observation so this is where t is also 0 let's say এখান থেকে আস্তে আস্তে আমাদের একটা certain amount of time let's say at time t1 the velocity final velocity of the object is v1 if we keep on observation let's say we do not stop the object we keep the acceleration same and the object speeds up further and let's say after another time over here let's say at time t equals to t2 the speed of the object is v2 now what you need to understand t1 মানে হচ্ছে 0 থেকে t1 মানে শুরু থেকে এই পর্যন্ত maybe this is let's say 4 seconds t2 মানে হচ্ছে শুরু থেকে এই পর্যন্ত let's say this was let's say 6 seconds or 7 seconds t2 doesn't mean the time between t1 and t2 t2 means the time from the start all the way up to this point so এরকম যদি আমি আরো অনেকগুলো different instances আঁকি যে let's say at time t3 the object had a final speed of v3 the proportionality tells us that the ratio of all of these things v1 by t1 v2 by t2 and v3 by t3 all of these ratios should be exactly same that's the physical meaning of that proportionality বুঝা যাচ্ছে এই ড্রয়িংটাকে বুঝা যাচ্ছে
So this is only if acceleration is constant.
acceleration has to be constant or acceleration has to be constant for any of these four formula to be applicable that's a given for variable acceleration case this formula cannot be applied এই ফর্মুলাগুলো শুধুমাত্র একটা কনস্ট্যান্ট অ্যাক্সেলারেশন কেসের জন্য অ্যাপ্লাই করা যাবে different acceleration এর জন্য এই ফর্মুলাগুলো অ্যাপ্লাই করা যাবে না if a certain object's motion is comprised of multiple different accelerations then we have to apply this formula individually for the exclusive duration for which the acceleration was constant so যতটুকু পারে আমি একটা एग्जांपल দেখাই মনে করো একটা certain objecটের vt গ্রাফ মনে করো হচ্ছে এরকম boom 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 and bam মনে করো একটা অবজেক্টের ভিটি গ্রাফ এরকম ইউ ডু আন্ডারস্ট্যান্ড যে এই পয়েন্টের অ্যাক্সেলারেশন গ্রেডিয়েন্ট এই পয়েন্ট এই লাইনের গ্রেডিয়েন্ট এই লাইনের গ্রেডিয়েন্ট এই লাইনের গ্রেডিয়েন্ট এই লাইনের গ্রেডিয়েন্ট এই লাইনের এই সবগুলো লাইনের গ্রেডিয়েন্ট এক্স্যাক্টলি সেম না আই হ্যাভ ট্রাইড নট টু ড্র প্যারালাল লাইনস বাট ভিজিবলি যেটা দেখা যাচ্ছে যে আমাদের এই দুটো লাইন মোস্ট লাইকলি প্যারালাল আচ্ছা এই দুটো লাইন প্যারালাল হইতে পারে সমস্যা নাই বাট দ্য পয়েন্ট ইজ আমি এই টাইম থেকে এই টাইম পর্যন্ত এক্সেট ইকুয়েশন অ্যাপ্লাই করতে হবে কারণ এই পার্টটুকুর মধ্যে অ্যাক্সেলারেশনের একটা কনস্ট্যান্ট ভ্যালু আছে আমি সরাসরি আবার এখান থেকে এই পর্যন্ত টাইমের জন্য আরেকবার ইকুয়েশন অ্যাপ্লাই করতে হবে এখান থেকে এই পর্যন্ত আরেকবার ইকুয়েশন অ্যাপ্লাই করতে হবে